starting.
Okay, so we just completed homework number 42. So I'm going to give you guys, I'm going to go over the homework, a few of the problems from that homework right now. But what I want to recommend is this time I am wanting to purposely split going over the homework and going over the new material into two different videos. I accidentally did that on the last set of videos. Didn't even mean to, but that's what happened. But with this one, I am purposely splitting up the homework portion, going over the homework 42's homework, and then explaining the stuff for homework number 43. I'm separating those because I think that it's a good idea to have a little bit of break in between. Absorb this stuff that I'm going to go over 42. You want to, I don't want to get you information overload. So I want you to come back with a clean, fresh mind to absorb the new stuff, because there's going to be a lot of stuff coming at you. It's not super difficult, but it is kind of strange and kind of different, and you haven't seen it before, and it, you know, it's like I said, it's not that hard, but it is weird. The notation is weird, and so you just need to be ready to absorb it. So I think it's best if you just watch this video to cover the homework number 42 problems. I'm going to do some of that from there. I'm going to stop the video. The next video is going to be explaining the new material. Come back to that with a fresh mind, and I think it will be beneficial. So here we go. The first one, number 14, says log x is negative 2.91. Remember, that means log base 10 of x if nothing's written there. So if I convert, that says 10 to the negative 2.91 power is x. So what is 10 to the negative 2.91 power? I don't know, but my good buddy Cal knows. So let's figure it out here. Let's see. 10 x to the y, 0.291. Then I hit the plus or minus. Whoa, something's wrong. Wait. 10 x to the y, 2.91. Hit the plus or minus that makes it negative, and then equals, and I get, now let me show you what I get when I do that. I'll up here on the screen. Hey, up here, right there. Okay, that is the problem. Now when I type into the calculator, that's what it spits out on my calculator. 1.230268771 negative 03. What does that negative 03 mean? It doesn't, well, what it does mean, it doesn't mean this thing to the negative third power. What it means, it's scientific notation. This guy times 10 to the negative 3 power. What does that mean? That means you put this number 1.230268771 and you move the decimal 3 directions. In the negative exponent direction is this way. So, or the negative, yeah, the negative direction is that way. So 1, 2, 3, the decimal goes there. So the 3 significant digits is going to be 0.00, wait, let's see, 0.0, yeah, 00123. And that, you know, that's going to be what it is. So just understand, when you see something like that, to the negative 03 power, it just means times 10 to the negative third power. It means this would be the answer. Okay, good enough. Okay, this guy, 12 to the 2x equals 1,000. Oh, that's right here. I have that written right here. Okay. Well, I can't make 12 and 10,000 powers of the same base. It would be nice if I could, but I can't. So what am I going to have to do? I'm going to have to take log of both sides. So log of 12 to the 2x is log of 1,000. Okay, then help, I'm afraid of the heights. Get me down from here. Okay, I'll do that. 2x log 12, that's the third law of logarithms, equals log of 1,000. And then divide by 2 and divide by log 12. I'm dividing by 2 log 12. 2 log 12. Okay? And then that's That's one way to put my answer. Actually, this problem, there are several ways you can put your answer. Let me show you some of them. Okay, that's fine. That's a great answer in calculation ready form. Now, all these other ways I'm going to show you should give you the same decimal approximation. Okay, but one thing to notice, log means log base 10. So log base 10 of 1,000 is going to be 10 to what power gives you 1,000? Well, that would be 10 to the third power. So log of 1,000 is just 3. You could write that as 3, right? Over 2, you could put it over 2 log 12, right? That'd be fine. But also, you could pump that 2 up as an exponent there, and call it 3, which is this, log 1,000, over log 144, because 12 squared is 144. So that would also be correct. All of these are correct. Or even log 1,000 over log 144. Any one of those is correct. They all are going to give you the same decimal approximation. In fact, it's going to be that when you type it in. When you type in any of those guys, if you do them correctly, you get that, which is to 3 significant digits is 1.39. So there we go. Okay, this guy right here, number 22, 4 to the 2 minus t over 3 equals 7. Okay, look, blah over 3 equals 7. The best thing you can do now is to get rid of this divided by 3 by timesing by 3. Times by 3 cancels that. But if you times that side by 3, you got to times that side by 3. So you get 4 to the 2 minus t equals 21. Okay, so far so good. Now, I can't make 4 and 21 powers of the same base. It'd be nice if I could, but I can't. So I'm going to take log of both sides. Okay, so log of 4 to the 2 minus t is log of 21. Remember, log means log base 10. Okay, now I can move this guy out front. Now it's a binomial, it's 2 terms. So I'm going to actually use parentheses right here. Log 4 equals log 21. Because it's that quantity times log 4. So I would have to distribute the log 4 to both of those if I wanted to distribute it. But you know what I'm going to do instead? Instead of distributing the log 4, I'm going to say, hey, I can divide by log 4, like that, which will cancel that. And then I get 2 minus t is log 21 over log 4. And then minus 2 from both sides. And I would get, there's a couple ways you could look at this. Minus t is this guy minus 2. So, but wait a minute, I don't want to know what minus t is. I want to know what regular, well look, if minus t is this guy take away this guy, then regular t would just be this guy take away this guy. It'd be flipped around. That's the way I'd look at it. 2 minus log 21 over log 4. And there's the answer in calculation ready form. If we want to convert it into a decimal, I don't know if I have it calculated up here. Oh, I don't have it. I'd have to figure it out. So let's see. It would be, okay, I'm going to do, here's what I would do. I'd do log 21 divided by log 4, which gives me 2.196. That's just this guy. But notice what I'm going to do. Well, that's like this guy. Then I'm going to minus 2 from it. But that gives me negative t, right? That doesn't give me regular t. It gives me negative t. So I have to take the opposite of that. Right now it gives me 0.19615. So 0.196. So t must be the opposite of that. So t must be negative. Is it 0.1? Yeah, 0.196. 0.196, like that. Okay. There's that one. We're trucking along. Now, number 26 is one of the ones like we used to do in the good old days, like about a week or two ago. Remember, look, 8 to the x, 16 cubed root 2. Believe it or not, the variable's an exponent, but these can all be made powers of 2. So guess what? I don't need logarithms to solve this one. I'm going to go 2 to the third to the x, right? Because 8 is 2 to the third. 16 is 2 to the fourth times 2 to the 1/3. Cube root is 1/3 power. So we're going to get 2 to the 3x equals 2 to the 4 plus 1/3. Well, what is 4 plus 1/3? 4 is 12/3 plus 1/3 is 13/3. Dan Marino thirds. Wait, I wrote that wrong. Okay. Let's see, it's 2 to the 13/3. So 2 to the 3x is the same as 2 to the 13/3. So what do? Throw away the 2's and set the exponents equal to each other. Hey, to get rid of times 3, I'm not going to divide by 3 because that's a fraction. I'm going to times by the reciprocal. And I get x is 13/9. Oh my gosh. There we go. Cool. Now, let's see about this one, number 30. I would convert from this, probably the best way to do is convert it into an exponential form. There's a couple of approaches you could take. This isn't necessarily the way you have to do it, but x to the 3/5 equals 900. That's probably the best way right there. Okay, now, I don't want x to the 3/5. I want regular just x. If I just want x, I'm going to have to raise to the reciprocal power, which is 5/3, right? That means I got to raise this to the 5/3. So x is, oh my gosh, that was easy, 5/3. Oh my gosh, can you believe it? I just have to let my good old buddy Cal figure this out now. 900 raised to the power, x to the y, is, oh, by the way, I just thought of something. X to the y there, to 5/3, so parentheses 5 divided by 3, close parenthesis, equals, holy moly, 83895.2, so 83895.27766. 27766. Okay, so let's see what that is. That's going to be to 3 significant digits. This would bump up to a 9, so it'd be 839 and then 2 zeros. So there you go. The thing that I just thought of right now that I don't know if I've mentioned it before, but if you're back on a TI-83, I've been talking about the y to the x key a lot. You know, x to the y or y to the x like this. Okay, this is very important. Listen to what I'm going to say here. Is the TI-83 or some of the other calculators, other than that, they have their button that's y to the x or x to the y is called a caret. Looks like that. That is the same thing as an x to the y key. So when I've been saying x to the y or y to the x, that thing is the same thing. So if you're looking on this, you won't find an x to the y key or a y to the x key. You will find the little caret. And it is located right below the clear button right there. Right below the clear button is the caret. That means raised to the power. It's the same thing as the x to the y or the y to the x key. That just struck me right now, so I just thought I'd mention that to you. Okay, so let's see, this guy, 32. Again, wait, this guy divided by 9 equals 7. I don't want divided by 9, so I'm going to times everything by 9, which cancels that. When I times by 9, I get 5th root of x equals 7 times 9 is 63. How do I get rid of a 5th root? How about if I raise to the 5th power? 5th power, so x equals 63 to the 5th power. So I just have to say, what is 63 to the 5th? I'm going to do it on this one just so you guys can see how this one works. This is the one that has the caret. So I'm just going to do 63 caret raised to the 5th power equals, and it's 992,436. I don't even know how big this number is. 992,436. 543. Holy moly, what in the heck number is that? Let's find out. You go 3 over, there's 1,000, million, 992,436,543. Rounded to 3 significant digits, it's just 992 million. There we go. Right on. So there's that. Then, oh, we already did that. Okay, now we're going to be solving some other equations. This is still going over that last homework. That's why I'm telling you, it'd be nice to when we get done with this portion of it, for you to take a little break before you go into the next stuff. All right, let's see. Here goes. All right. 3y minus 1 to the 6th power. 3y minus 1 to the 6th power equals 80. Well, a couple ways you could do this. You could take the 6th root, but 6th root is the same as raising to the reciprocal, the 1/6 power. So I could do this. I'm going to call it raising to the 1/6 power. So I get 80 to the 1/6 power. If I raise this side to the 1/6, got to raise that side to the 1/6. Notice 6 times 1/6 is just 1. So it's going to be this guy to the 1st power, which is 3y minus 1 to the 1st power equals 80 to the 1/6 power, which is an ugly number. It's going to be an ugly number, the 6th root of 80. Okay, we're going to add 1 to both sides. Cancel that. 3y is 80 to the 1/6 power plus 1. Divide by 3 to get rid of times by 3. And this will actually be my answer in what they like to call calculation ready form. Let's plug it into the calculator and see what we actually get. Okay, I'm going to do 80 to the 1/6. So I'm going to do 80 raised to the power, parenthesis, 1 divided by 6, close parenthesis, equals, that's like 2.075 or whatever, plus 1 equals 3.075 divided by 3 is 1.0252, so about 1.03 approximately. So there you go. Okay, this guy, 34. Cube root of 4x plus 3 equals 8.15. Actually, very similar to the problem we just did. I can get rid of this 3rd root by 3rd powering. So look, 3rd power, 4x plus 3 equals 8.15 to the third power. Now you might say, I don't know my 8.15s very well, but that's okay, because I have a good buddy named Cal that knows all that stuff. We don't have to know them. Equals 8.15 to the third minus 3 divided by 4. X is 8.15 to the third power minus 3 over 4. So here we go. So I'm going to do 8.15 raised to the third power equals about 541.34 minus 3 equals 538.34 divided by 4 is about 134.5858438. So about 135, we will call it, to 3 significant digits. So X is approximately equal to 135. Okay. Okay, the change of base. Remember we did that last time. Change of base formula. Very simple. To do log base 3 of 40. First of all, let's figure out what we expect for the answer to be. Okay, look at my multiples of 3. 3 to the first is 3. 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. Well, guess what? 40 is between 27 and 81. So guess what? I would expect this answer to be somewhere between 3 and 4. In fact, the answer is going to be, watch, I'll predict this, 3 point something. That's what it's got to be. 3 point something. It's somewhere between 3 and 4. Let's find out. Here's how you do change of base. Log of this guy over log of this guy. If we do that, it should end up giving us 3 point something. Let's find out. So I'm going to go 40 at log, gives me 1.6020599. Okay, divided by 3 log, which is only showing log 3 now, which is 0.477. Now when I hit equals, 3.35776, so about 3.36. Oh my gosh, I thought it was 3 point something. How about that? It was, and it's 3.36. We knew it was going to be 3 point something. Now we know, 3.36 rounded to 3 significant digits. All righty, I think that's it. Let's see. Yep, that's the next thing. So yeah, so here's what